Then we'll talk about the boundary conditions, what type of boundary conditions are available in MIDAS Civil and where we can use them. Then I'll talk about the load and the load cases. Finally, we'll talk about the analysis options available. And lastly, we'll look at some of the design options available in MIDAS Civil. MIDAS Civil is a 3D structural analysis and design software based on FEM analysis. The following structure types can be analyzed in MIDAS Civil. As you can see, the list of the structure types that we can analyze in MIDAS Civil includes the slab bridges, the culverts, the frame bridge, the integral bridges. We can also do the analysis of composite precast girder bridges, and we can also do the staged construction analysis. We can also do the cable stayed bridge analysis. Various functions are available for the same. And finally, we can also do the railway bridge analysis. As apart from bridges in MIDAS Civil, we can also do the analysis of subway station and purification plants. We can also perform the soil surface interaction analysis. And moving on to the dynamic and advanced analysis, MIDAS Civil provides the seismic analysis such as response spectrum analysis, pushover analysis, and many more. So this is a list of the analysis types that MIDAS Civil covers. MIDAS Civil can do moving load analysis, construction stage analysis, P delta, eigenvalue, heat of hydration analysis. It can perform both the geometry and the material nonlinear analysis. And finally, pushover, time history, and response spectrum analysis can be done in MIDAS Civil. MIDAS Civil use the following three types of elements for the generation of bridge model. We can define one-dimensional elements such as truss, cables, or compression only members. We can also model the structure using 2D elements such as plates or plane, asymmetric plane, and we can also generate the model using 3D elements such as solids, 4-node solids, 6-node, and 8-node solids. MIDAS Civil equips the user with a variety of graphic user interface features. As you can see, this is the work window of MIDAS Civil. On the left hand side is what we call the tree menu. In tree menu, all the functions, all the modeling features, the load and the load generation features are available. The user can quickly select what he wants from the tree menu. On the right hand side are the certain features that can be used to see the model in a variety of directions. On the top, as you can see, the node, the element, the user can also select the various functions from this. Through this advanced webinar, I will tell you how to model a curved bridge and the various kind of supports provided to it in the coming slides, and I will also model the same model in my presentation. As you can see, this model contains curved beam elements, it contains solid elements, and variety of features available in MIDAS Civil have been used to generate this model for the better understanding of the users. MIDAS Civil equips the user with variety of wizards such as beam wizards. Starting from the simple beam wizard, MIDAS Civil equips the user with wizards for advanced bridges such as suspension bridge, cable stayed bridge, FCM bridge, MSS bridge, and many more. In MIDAS Civil, you can import the DXF file which can be used to model any structure, and you can, after importing the DXF, you can perform the analysis and see the results. You can import not only AutoCAD but several other features files available. Here I would like to import a simple model in front of you to demonstrate how we can import the AutoCAD file. You can provide the material properties or the section property herein, or you can modify them later on. As you can see, I have imported the cable stayed bridge, and now after importing this, I can define certain section properties and assign to these members and perform the analysis. There are certain important considerations that the user need to follow for importing the AutoCAD file. If the elements are made of line in AutoCAD file, then they will be imported as beam elements. If there is a polyline rectangle, then it will be imported as plate element. And if it is a 3D face, it will be again imported as a plate element. Solids cannot be imported, and the unit system must be consistent. If your AutoCAD drawing has the meter as a unit system, then the unit system of MIDAS Civil, while importing the AutoCAD file, as you can see here, it should be meter. MIDAS Civil equips the user with a variety of material properties. The material properties can be defined for American code, Euro code, and many other codes, as you can see in the front of your windows. We can define either the concrete or the steel or the SRC material properties. Also, the time-dependent material properties can be defined using the following codes, such as ASTO, ACI, and CEB. MIDAS Civil equips the users with a variety of sections. In MIDAS Civil, you can not only define simple sections such as the I sections or the rectangular sections, but you can also define the combined sections. MIDAS Civil has a database of many codes that you can use for defining these sections. The user can also define the SRC section. For defining the SRC section again, the user can select whether he has to enter his own values and own dimensions, or the database has to be used. In MIDAS Civil, you can select a variety of PSC sections available. You can select 1 cell, 3 cell, or n cell sections. You can specify the number of cells, and then you can model the girder using these sections, and you can perform the analysis. Here also in MIDAS Civil, there are certain sections that are defined in certain codes, and you can use them directly. Again, if your section doesn't match to any of these sections, the sections that you are using for the construction of the bridge doesn't match with any of the sections, you can import the section from SPC. SPC is a special module of MIDAS Civil with which you can create the section, or you can import the section from AutoCAD DXF file and create the section out of it. SPC calculates the properties of the section and export it to MIDAS Civil for analysis and design. The user can also select certain tapered sections as available, and if the user can also select the composite sections, and if the section doesn't match with the section that you're going to use for your bridge, you can import the section from SPC again. So now let me quickly take you through SPC. to tell how this function works. First of all, we define the unit systems. Here I will make a simple section and export it to MIDAS Civil, where it can be used for analysis. I will make a composite section having 3 parts. I will give it an arbitrary value of modulus of elasticity and density. I am defining different materials for different parts of the composite section. And now I will make the geometry. So as you can see, I have made a very simple composite section having 3 different rectangles, and now I will generate a composite section having 3 different parts using SPC. So I'll go to model section and composite section, and I'll generate a composite section having 3 parts. As you can see here, you can have maximum 4 parts. I will define the base material and I'll give the name to the section. So I have created the composite section. Now I will add parts to this composite section. So first I will add the part named as top. I will give it as an ID of 1 and the material as material 1. So as you can see, the first part has been generated. Now I will generate the mid part and I will assign it the material known as material 2. Again, I will select all the lines defining the section. I will give it a different color and the material will be second material. And thirdly, I will generate the third part having the third material. And I'll give it an ID of 3. So as you can see, 3 parts have been generated, and now I will calculate the section properties. And the section properties have been calculated. You can see the section property at list section property, and you can see the section properties for the 3 different parts individually. And now I will export this section to be used for analysis in MIDAS Civil. I will give it a name. Composite section. I will select the section and click apply. So my modeling of section in SPC is complete, and now I will import the section in MIDAS Civil. Since it is a composite section as we defined in SPC, so it will be imported under the composite tab. I will give it a name, and my section has been imported. So now when I'll make a beam here with this section, I'll define a material, and as you can see, the 3 parts of the section, the composite section that we made, have been imported in MIDAS Civil, and you can define different materials to them, and you can activate them in different construction stages as applicable. When we define the PSC section in MIDAS Civil asks for the mesh size. Now I will tell you what is this mesh size about. Here, MIDAS Civil asks the user to enter the mesh size for the stiffness calculation. In MIDAS Civil, the torsional moment of inertia and the effective shear area are calculated by considering the section defined by the user as a cantilever beam, and that MIDAS Civil applies a unit load at the centroid, and by obtaining the deflection for this meshed beam, the torsional moment of inertia and the effective shear area are calculated. In MIDAS Civil, the elements can be created in a variety of manner. You can either create the elements by making nodes, or you can create the element using grids. Let me show you quickly how we can make the elements using grid. As you have seen, I have defined the grid, and I'll create the elements using this grid. Also, if I have certain nodes, as we have two nodes here, I can create the section by connecting the nodes. Or I can use the structure wizard for the beam or the column for generating the beams or the columns. In MIDAS Civil, the elements having a curvilinear profile can also be generated. And now I will go to my previous purpose. I showed you a model, and I will model the same bridge in front of you, and I'll show you how easy it is to create the elements having the curvilinear profile in MIDAS Civil. So first of all, I will define the section for the girder of the bridge. I will define a composite section for the girder. The bridge will have the width of 15 meters. It will have 5 girders, and the center of center spacing will be 3 meters. Here I would like to tell you that we have to enter the total slab width for the calculation of the IZZ, because in real practice the deck will be continuous, but when we model the same deck in MIDAS Civil, it will be modeled along with the beam. So for calculating the IZZ, the program asks the user to enter the entire slab width, and then the IZZ for the entire slab width is calculated and divided among the girders. When we model the bridge using the grillage model, then the girder number should be 1 always, so that because while generating the bridge from the grillage model, the program itself takes into consideration the role of IZZ. Now I will define the section. And now I will select the material for the steel and the concrete. As you can see, the section has been designed. Now I will select the function known as create line elements on curve to create the curvilinear profile of the bridge. I will define a material. As you can see in front of your screens, the curvilinear profile of the bridge has been modeled. And now I will select the recently created elements using this function and translate it in Y direction for the generation of other girders. And as you can see, I have modeled the entire width of the bridge using the composite sections. MIDAS Civil has a special feature known as extrude elements. With the help of extrude elements, you can extrude a node into an element, or you can extrude a beam element into a plate, and the plate can be extruded into a solid. I will demonstrate how we can do that. First of all, I will select the nodes and I will extrude the nodes to create the beam elements. As you can see, I selected the nodes and MIDAS Civil has extruded the nodes into line elements and the bridge profile is completed. Now I will model the pier cap. For modeling the pier cap, first I will translate these nodes in the negative Z direction, and then I will create the pier using the creation of beam element by nodes. I will translate these nodes in the negative Z direction. As you can see, the nodes have been translated. Now I will define the section for the pier cap. The pier cap will have a rectangular section having the dimensions of 2 meter by 2 meter. And I'll create the pier cap. First I will select the section for the pier and then I will create the pier cap. Now you can see that the elements are overlapping, but this is not the scenario in the real construction process. So we will change the offset of pier cap from center to center top, and now you can see there is no overlapping between the girder and the pier cap, and hence the real construction scenario is followed. Now I will create the pier. For that I will translate this node in the negative Z direction again, and I will use the extrude function of MIDAS Civil to create the pier. I will extrude node into line element and I will define a section for the pier. The pier will have a round section of diameter 1 meter. I will define the section to be pier section, and I extruded the node to create the pier. Now I will create the footing under the pier using solid elements. For modeling solid elements, I will follow the process of extruding a node into an beam element, and then I will extrude the beam element into a plate element, and then I will extrude the plate element into a solid element. First of all, I'll select the node and I will select the extrude function of MIDAS Civil, and I'll give it an arbitrary section because this beam element will have no purpose, so I give it an arbitrary section. So as you can see, the line element has been created, and now I will create the same element on the other side by using the mirror function. I will copy these beam elements on the other side, and my entire length of the footing has been modeled. Now I will select all these elements just created and extrude them from line element to planar element. I will extrude them as a plate. I don't need to define any thickness here because the purpose of making of the plate is to model the solid element. So as you can see, I have extruded the line elements to create the plate elements. Now I will select the plate elements by using the select identity feature of MIDAS Civil, and I will copy these plates in the negative x direction to obtain the entire width of the footing. As you can see, the entire width of the footing has been modeled. Now I will select all these line plate elements and I will extrude them to make the solid. I will extrude them in the negative z direction, and the solid has been modeled, as you can see. Now I will copy the pier and the pier table further, so that I can create the pier and the pier table for other supports. So as you can see, the pier table and piers have been copied to other supports. For the making the footing at this place, I will use the plate wizard feature of MIDAS Civil. And as you can see, using the plate structure wizard, you can quickly generate the plate without following the process of node to element, element to plate, or something like that. In MIDAS Civil, you can change the element parameters such as material, section, or the beta angle by following the element table. You can create the element table and you can therein change all the section all the element parameters, or you can change the element parameters such as material, section from the works tree. And finally, clubbing both of them together, we can use the function known as change element parameters. You can use the change element parameter function of MIDAS Civil to change the material ID, section ID. It becomes very helpful when we have to change the element type. So you can select all the elements and you can change the parameter to cable, hook or general beam as desired. In MIDAS Civil, the structure mass is automatically determined by the program by considering the material density. But the user can also define the additional mass using model masses. The user can define the nodal mass at certain nodes, or the user can define the loads, and he can convert the load to mass. As let's say I apply the nodal loads at these beam elements, I can select that load case and I can make the mass out of it. Now let's talk about the supports, the various supports available in MIDAS Civil and how we can use them. In MIDAS Civil, the simple supports such as pin supports or the fixed supports can be simulated by the function known as supports. You can restrain either X, Y or Z, or you can restrain the rotations at a node. In MIDAS Civil, the point spring supports are provided to simulate the soil conditions. The non-stiff characteristic of the soil can be simulated by using this feature, and I will use this point spring support in the model that I am creating to let you know how can we apply that. For using the point spring support, I will generate the piles at the base of this footing. For that, I will select the nodes. I will activate the nodes. After activating the nodes, only the nodes can be seen in the entire model. It becomes very helpful when we have to do the modeling in minute places. So my pile will be at the following 5 locations, and I will again use the extrude function of MIDAS Civil to generate the pile. The pile will have the length of 10 meters and it will have a circular section having 0.3 meter diameter. I will select the section as pile section and I'll make the piles. As you can see here, the piles have been modeled. And now I will activate the whole model and I will copy these piles and the solids to other location resembling the same footing. So I will translate these footing and the piles to other piers. So I will translate it to create the footing at the other piers. As you can see, the footings have been translated and modeled. Now I will apply the point spring supports at the piles to simulate the soil support. So I will select all the piles nodes and I will go to Model, Boundaries, and Point Spring Supports. I will define the soil characteristics. How to define these spring characteristics of the soils are available in certain engineering books. User can refer to it for the same. And we have simulated the soil conditions, and we have provided the point supports to the pile. There are 4 types of springs that can be defined. We can define the linear, compression only, tension only, or the multilinear spring. The multilinear spring becomes specially useful when we have to define the different spring constant for different forces. As you can see, the user can define the own stiffness. How does the stiffness varies along with the force. In MIDAS Civil, the user can also apply the surface spring supports. The surface spring supports are generally used to simulate the soil conditions underneath a footing, because footing is placed on the soil and it has a continuous support. The user can enter the subgrade modulus of soil and he can generate the load, the boundary condition. The boundary condition in this dialog box can be created in 2 ways. The user can either define the nodal spring or he can go for distributed spring. Nodal springs, with the help of nodal spring, MIDAS Civil automatically calculates the spring constant associated with the subgrade modulus. The spring constant is calculated by multiplying the effective area associated to a node to the subgrade modulus, and the support is provided at the node. But by using the distributed spring feature, you can apply the real continuous support at the base of the plate or the frame element. The support can also be provided to the solid element. MIDAS Civil equips the user to provide elastic links between 2 nodes. They are especially helpful when the 2 members are connected via springs. There are certain types of elastic links that are available in MIDAS Civil. The user can select the tension only, compression only, or the multilinear elastic link, where the user can define the own force versus deformation diagram, and MIDAS Civil will use this for the analysis. As you can see here, the girder and the pier, the nodes at the girder and the pier have been connected using the elastic link which simulate the bearing characteristic. We can also simulate the ballast characteristic by using the multilinear type of elastic link. It is especially helpful for the analysis of the longitudinal forces. In MIDAS Civil, the user can also specify the beam end releases. With beam end release, the user can release some of the constraints associated with the beam elements for a specific point of time. It becomes very helpful when we deal with the composite bridge, because in composite bridge, the girders become continuous only after the laying of the deck. So the user, as you can see in front of your screens, the first image shows that the girder are not continuous, and the second image shows that the girder have become continuous after the laying of the deck. The user can constrain or deconstrain Fx, Fy, Fz, or the rotations at X, Y, and Z by using the beam and release feature. In MIDAS Civil, the rigid links can be provided to connect the nodes which cannot move relative to each other. This feature is specially used to connect the nodes representing the same solid. The rigid link can be provided to restrict either of dx, dy, dz, or you can restrict all of them together. As you can see here, this model has been prepared to analyze the web opening, and only at the portion where the web is there, the plate elements have been used to model it, and after a certain distance from the web opening, the beam elements have been used to model it. But since these plate elements, the section modeled by using plate elements represent the same beam element, so it has been rigidly connected to the beam element. Let's see where we need the rigid links in our structure. As you can see, there is no connection between the pier and the pier cap. But in reality, the pier cap and the pier are connected rigidly. So we'll apply the rigid link to connect the pier and the pier cap. And we will restrain all the degrees of freedom and I will copy the rigid link in the X direction so that the connection between the piers at other two supports can also be modeled. As you can see, the rigid links have been provided. Again, if we carefully look at the support, it contains the pier connected rigidly to the solid elements representing the footing. But in MIDAS Civil, the program doesn't know this. So we'll apply the rigid link representing the connection between the footing and the pier. For that, I will select the nodes and I will select the pier and I will activate them to do the modeling at these locations only. So this is the actual scenario. This is the actual connection that we have to achieve. We have to connect these nodes rigidly with the piers. Let's see what nodes have to be connected. As you can see, these part will be rigidly connected with the pier. So I will select the node that will act as the master node at the base of the pier. That will be node number 91. And now I will select the nodes that will be rigidly connected to this node. And the rigid connection has been obtained. And I have copied the rigid link so that this same support can also be provided to the whole structure. So as you can see, the rigid links have been copied. Now there is no connection between the girders and the pier cap. In the real scenario, we are supposed to provide bearings between them. And as I told you earlier, the bearings can be modeled using the elastic link. So I will specify the bearing spring stiffness representing the bearings. And and I will copy the elastic link in the Y direction to create all the bearings together. As you can see, the bearings have been generated. But the bearings have been generated only at one support. We have to copy these bearings at other supports also. We can do that by copying the node attributes. For that, I will first select the nodes whose attributes have to be copied. As you can see, I have selected the nodes representing in which the connection of the elastic link is provided. And I will go to translate nodes and I will copy the node attributes to the other locations. And as you can see, the elastic links have been copied. Again, the piles are rigidly connected to the footing and we have to provide the rigid link between them also. In MIDAS Civil, the user can define the node local access because sometimes the bridges are modeled so that the global x-axis doesn't match with the element local x-axis. For that, you can define the local node axis. I will define the local node axis because our bridge is also curved. For that, I will select the node first where I have to change the local axis. So these are the nodes where the bridge is curved, and I have to apply the angle which this element makes with the global x-axis. So I will do that by using the vector definition of angle, and I have applied the node local axis to these nodes, and when I specify the supports, now I can specify the supports to the node local axis and thus representing the real scenario. Let me clarify again. In this model, we don't need to apply the node local axis because we have modeled the bearings as elastic links. But this was just a demonstration to show you how to apply the node local axis and what is the function. In MIDAS Civil, the effective width scale factor can be applied to apply a scale factor to the moment of inertia about y-axis, the major axis, and this effective moment of inertia can be used to calculate the stresses at the top and the bottom fiber in a section, and we can also specify the scale factor for the calculation of section modulus of top and bottom of the section. This effective width scale factor is only used to calculate the stresses, and the force effects such as the bending moment diagrams are not affected by using this feature. We can apply the effective width. The user can specify the effective width here by specifying the scale, or user can also automatically define the effective width from the ASTO code. So that was all about the boundaries I discussed with you. Now I will discuss about the cases, the load cases. In MIDAS Civil, the following type of load cases are frequently used. There are other load cases also, such as the overload pressure, the crowd load, pre-stress and all. The user can define these static load cases. The definition is important because when the user generates the load combinations by using specific codes, then several factors are applied to different load cases. The self-weight of the member can automatically be considered by using the self-weight command. By defining By using the function known as self-weight in MIDAS Civil, you can specify the scale. What is the scale you want to apply for the self-weight of the structure? The user can also define the displacement of supports, because sometimes we see that the piers, there is a settlement in the piers or other supports, and to simulate that in MIDAS Civil there are two functions available. You can either use the specified displacement of supports to specify displacement to a variety of nodes, and this would be used for the determination of forces after doing the analysis. But here I would like to tell you something about what internally goes inside the program when you have defined the specified displacement. When you specify a displacement at a node where there is no support, the program internally applies a support while analyzing for other load cases which don't have the specified displacement. And to overcome this, in MIDAS Civil, you can specify different boundary conditions to different load cases. So let's say for the self-weight, you don't want to see the effect of settlement. Then you select the load case and the boundary condition you want to specify, and hence the effect of specified displacement will not be seen when we analyze the structure for the dead load or the self-weight. Also, MIDAS Civil equips the user with the settlement analysis data function. With the help of settlement analysis data, we can apply differential settlement to different nodes, and the program will automatically generate the load conditions by combining the nodes having differential settlement. Let's say I want to define the differential settlement for these three piers. So first of all, I'll define the settlement group. I will select these nodes and specify a displacement to them. And let's say the settlement at this pier was not 0.01 meter and it was 0.02 meters. So I have defined differential settlement to pier 1 and pier 2. And now I can define a settlement load case. And by defining this load case, MIDAS Civil will automatically generate the worst combination. The worst combination can be obtained by applying both the settlements or either one of them. MIDAS Civil will automatically generate what is the worst combination for generating the maximum positive and the minimum negative effect, and the user can see the analysis results. MIDAS Civil equips the user with a variety of beam loads. You can select the uniform loads or the concentrated loads for defining the loads on the beams, and you can also define the loads using some special load distribution functions. By specifying the typical functions, you can apply this special loading in a nick of time. MIDAS Civil also equips the user with a function for the defining of the wind load. Wind loads only act on the structure's width. So the user can select this by applying the uniform pressure, and this uniform pressure will be applied to the different widths of different elements, and this can simulate the wind load. The user can also sometimes on the top of the bridges we see the sound barriers, and the sound barriers creates wind load on the structures, but they are not structural components and they are not modeled in MIDAS Civil. So the user can use this feature known as additional edge from top, and he can define what is the height of the sound barrier, and MIDAS Civil will automatically calculate the effect of wind load due to this sound barrier on this structure. In MIDAS Civil, when you apply the pressure load to a plate, the load is applied on the entire plate, and for the solution of this, MIDAS Civil have come up with a function known as define plane load. If you want to define the load which is not entirely on the plate, on some of the plates, then you can define this plane load using the plane load feature of MIDAS Civil. You can define the load profile, whether it is a point load or a line load or an area load. As you know that in MIDAS Civil, the concentrated node can only be applied at certain nodal locations, but with the help of this feature, you can define where do you want to apply the load. This is especially useful when we model the bridge using the plate elements and we want to simulate the tire pressure exactly on the structure. The temperature load. MIDAS Civil equips the user to apply a variety of temperature loads. As you can see, system temperature, nodal temperature, and the temperature gradients. The user can select and analyze the structure for thermal changes, and the stresses will be seen. When we define the temperature load having temperature gradient, then the section type becomes very useful. If you select the PSC section, the program can automatically take the section width from the section, as you can see, because if you manually calculate the section width, it becomes very tedious task. So in MIDAS Civil, you can just click on this section option, and MIDAS Civil will automatically calculate the width for the determination of thermal stresses. In MIDAS Civil, when we applied the gradient temperature load, the self-restraint moment is automatically calculated, and even if the resultant force or the bending moment is 0 at a section, the thermal stresses can be expected. So the self-restraint moment of the section is responsible for the same. In MIDAS Civil, we can do the moving load analysis for a variety of codes. The user can select the vehicles from the database that MIDAS Civil has for these codes. You can see the variety of codes that are available. Let's talk about them one by one. When we define a traffic lane in MIDAS Civil, we can define the wheel spacing. The wheel spacing becomes very important to simulate the axial load, because axial contains two wheels and we can simulate the distance between them so that the analysis results are precise. You can also apply the lane on the lane element or the cross beam. The difference between them is that when you apply the lane on the lane element, then MIDAS Civil applies the load on that element where you have defined the lane and a moment associated with the eccentricity. While when you define the lane on the cross beam, the cross beams, first the load is distributed inside the cross beam and then it is forwarded to other structure. When we do the analysis having the girder bridges such as the PSC girder bridges which have only one lane element, then user can use this feature, and when the user wants to do the grillage analysis, then this feature becomes very useful. Since ours is a model representing the grillage model, so we will define the lane on the cross beams. For that, first we need to make the cross beams. So I will create elements which will represent the cross beams. But before that, we need to define a section for the cross beams. The cross beam represents, the cross beams do not exist in reality, but they simulate the deck. So I'll apply the deck dimensions to it. And now I'm ready to make the cross beams. Since this is a curved bridge, so the translate feature will become tedious to use, because then you have to apply different X values for translation to different cross beams, and hence I have used the node-to-node modeling feature. But for the later part, which is straight, I can generate the cross beams by translating them. As you can see, the cross beams have been generated. Now I will define a cross beam group so that I can define a lane upon them. First, I will select the cross beam groups. I can select this feature of MIDAS Civil. I will select the elements in the Y direction. And hence I have selected all the cross beams. I will create a structure group named as cross beams, and I'll assign all those elements into the structure group. Now I'm ready to define the lane. So I will select the cross beam and I'll assign the lane to the cross beams. Since this bridge is curved, so we need to define the lanes accordingly. We can do that by picking the element one by one or by defining the number. Here I will define the lane by defining the number. As you can see, the element number which have the curved profile are from 1 to 10. So I'll just write 1 to 10 and click on add. And the profile at the far end of the bridge is straight, so I will use the 2-point function, and I have added the full profile of the lane. And when I click on apply, as you can see, the curved lane has been modeled. Also in MIDAS Civil, if you have modeled your structure using the plate elements, then you can use the surface lanes for defining the lanes. You can also use the feature known as lane support negative movement at interior piers when you select the ASTO LRFT code. The function of this feature is as defined in the ASTO code section 3.6.1.3.1, that when we design the structures at the interior supports, the force effect has to be calculated by using 2 trucks, and 90% of the effect has to be taken for the design of the members at the interior piers. So by defining the elements who fall in this region, in MIDAS Civil you can define them under the lane support negative movements. The input can be the manual input by the user, or the automatic input is also supported. So if you use the automatic input and you assign your longitudinal elements to the structure group, then MIDAS Civil automatically determines which elements have to be provided in the lane support for negative movement. And if the user go for user input, then he should know that if an element falls in a category where the bending moment is negative at only one end, then the user should select only one end to define in the lane support negative moment. By defining the concurrent reaction group, the user can define certain nodes in this group, and he can see what is the value of the reaction when one pier has attained the maximum reaction. The vehicles can be defined from the standard, and the moving load case can be generated. In the moving load case, there are two loading effects, the combined and the independent. And I will tell you what is the difference between them. If you use the independent, let's say we have a bridge on which there is train on the one lane. On one side there is a train motion, and on the other side there is a vehicle motion. By using the combined effect, MIDAS Civil can calculate the combined effect of those two vehicle types on the bridge. Let me show you how we can do that. First of all, I'll define other lanes. So I will define the other lanes, and I will define them using the same elements but providing different eccentricity on the cross beams again. And I have defined the second lane. Similarly, I will define the third lane, and I will define the third lane as you can see. This lane has been defined outside the bridge, and we can control it by using the skew function, and you can provide a skew at the start and at the end, and the lane will be defined as such. Now I will define another vehicle. Let's say vehicle 1 moves in lane 1 only, and vehicle 2, that is a truck, it moves in lane 2. So here, if you select the independent option, MIDAS Civil will calculate the independent effect of these two vehicles on the bridge. But if you select the combined option, MIDAS Civil will combine the load effect of both of these vehicles to generate the maximum or the minimum bending moment. Let's talk about the moving load analysis control data now. Here you can select the function normal plus concurrent force. By using this function, MIDAS Civil calculates the normal force along with the concurrent force associated with the moving load analysis. If you select just the normal force, then when you see the bending moment diagrams, you can see the envelope. But by selecting this option, you can see the concurrent forces as well. You can select the load point selection to be inference line dependent point or all point. It becomes very helpful when you want the quick analysis because this function takes less time. In MIDAS Civil, you can also apply the lateral load due to water or soil on the structure. You can apply that using the hydrostatic pressure load. Here, you can also define the constant intensity. As you see in the presentation, this is a retaining wall and there is a load, superimposed load at the top of the soil, and then there is soil. So the soil will apply lateral pressure, and the lateral pressure will also have the contribution of this mass which is on the soil. So you can specify that in the constant intensity, and then you can define the gradient. The user can use the linear variation or the curved variation can also be applied. Now let's talk about the load combinations. In MIDAS Civil, the user can generate the load combination using the several codes available such as ASTO LRFT, the Indian code and the Euro code. The important consideration here is you can create the load combinations by the consideration of only the static loads or the construction stage loads. In several codes, the load effect which is generated during the construction stages have to be applied different factor, and we can simulate that by using this feature. Now let me talk about the buckling analysis. In buckling analysis, by buckling analysis, I will open a model and show you how the buckling analysis is done. So I want to do the buckling analysis of this column. So I will model the column and specify the self-weight and the nodal loads, and I apply the boundary conditions as you can see here, and I will apply the buckling analysis control to tell the program that the buckling analysis has to be done. Here there are two options available. Either you can apply the positive value only option or the search. By using the positive value option only, the program considers the load in the direction of the gravity. But if you specify the search, the user can also apply the load in the direction parallel to the gravity, anti-parallel or parallel to the gravity. Here you can see there is a function known as consider axial force only. This function is useful when you don't want to have the effect of lateral torsional buckling in the buckling analysis. Then you can see the load type as variable and constant. It becomes helpful when the self-weight has to be specified. There are certain load cases which you want to be constant and certain variable. The self-weight, I want the analysis such that the self-weight remains constant and the nodal load is variable. So I can select the load case and the load type, whether it is variable or constant, and I can add and I can perform the analysis. And after performing the analysis, we can see the buckling shapes. As you can see here, it shows the buckling shape in mode 5. You can also see the buckling shape in multi-modes. As you can see, the buckling shape in various modes have been displayed. In MIDAS Civil, you can not only do this buckling, but you can also do the lateral torsional buckling analysis and the local buckling analysis. For that, I will open a model having plate elements, and I will show you how you can perform the buckling analysis. So I modeled the element, the beam element, using the plates. So it has an opening at the center, and this opening has been modeled using the plate elements. And I have applied the buckling analysis control, and I applied a beam load as a variable type for doing the buckling analysis, the local buckling failure of this beam. So when I see the buckling mode shapes, I can see the local buckling. As you can see here, the local buckling has happened in this plate, and you can see the deformation diagrams associated with it. Again, you can see the multimodal diagram and how does it change. So that was all about the modeling and certain analysis features available in MIDAS Civil. And now I would like to tell you something about the results. In MIDAS Civil, you can see the beam diagrams, which shows the bending moment and the shear force diagrams. You can see the stresses. You can see the PSC stresses at 10 different positions, and there are several components that you can see. You can also define the user-defined diagrams. For that, so let's say I want to see the bending moment diagram for the moving load. So as you can see, the moving load, the MV max, which represents the maximum positive bending moment generated by the moving load, you can see here. You can also select MV min, which shows you the maximum negative bending moment associated with the same. You can also see the pre-stressed stresses due to the moving loads, and you can see how does the stress vary along the length of the bridge. You can select several components such as axial, and due to moment you can select the summation, and you can see the stress generated by the moving load due to axial force and the moment in the major and the minor axis. You can define a diagram that you want to see. Let's say I want to see the beam force, or let's say the beam force at element number for the bridge girder group. Let's say I want to see the bending moment, so I have selected the bridge girder, the whole bridge girder. You can select individual elements also, and you select the bending moment, and let's say I give it a name, bridge diagram. And now I select the bridge diagram and I click on plot, and the bridge diagram has been plotted, and you can see the values displayed. Special feature of this function, the user defined diagram, is that we can see the shear force or the bending moment at the same time. So you can select, when you go to the user defined diagram, you can select which beam force do you want, and you can add it here. So let's say I defined the diagram for shear, and when I go to the plot diagram, I can see the shear force and the bending moment together. As you can see, the shear force values are very small compared to the bending moment, and hence it looks like only one diagram is displayed, but actually both of the diagrams have been displayed. You can also generate the influence lines for the beam forces, moments, etc. As you can see, the influence lines have been generated, and the influence lines are generated for different wheels. So let's say we have defined two vehicles, so they will have four wheels and four influence lines have been generated. So as you can see here, two lanes have been defined. That means four wheels in total, resulting in four different influence line diagrams. You can also use the feature known as moving load tracer to see the position of the vehicles for the maximum bending moment or the shear force at a particular element. So I selected an element and I want to see the vehicle position when it achieves the maximum bending moment. So moving load tracer shows you this position. You can write that you can convert this load into a static load, and you can also apply that load to the same structure to obtain the concurrent forces. So this becomes very handy when you want to see the concurrent forces after analyzing the model. There are certain advanced results available which we will cover in our another series. Right now this webinar, advanced webinar, is for the basic concepts, so we won't cover that. Now let us discuss the plate diagrams in front of you. So this is a model generated by plates. You can see the plate forces or the bending moments accordingly. You can see the plate forces in the local direction, or you can see the plate forces in the UCS direction. As you can see, the plate forces in the UCS direction have been displayed. If I want to see the MXX of the plate for these plates, then I will have to change the user coordinate system, and once I changed it, I can see the stresses at the plates. So this option, with the help of this option, you can see the plate forces along for the local axis or for the current UCS axis, and the UCS axis can be changed using model user coordinate system. The user can also see the wood armor movements. The wood armor movements become specially useful for the designing of the slabs. The user can also see the cutting diagram. For seeing the cutting diagram, we first define the cutting plane or the cutting line accordingly, and then we can see the diagrams. The user can also see the local direction force sum. Since here the elements are plate elements, so individual results are obtained for all the plates. If you want to see the results at a certain location, what is the total force effect, then you can select that. Let's say I want to see the force effect at this position. So first I will select that line. I will select the load case, and I will select the plate edge polygon select, and now I will select the polygon Here one thing has to be noted, that the polygon has to be selected in the anti-clockwise manner. It becomes very tricky when you have a lot of plates. So as you can see, I've selected the line and the results can be seen, which is the force sum of the force effect at this line. You can also generate the result tables for the force effects. You can generate the result table for the plate forces, beam forces, and you can also generate the text output. With the help of text output, the user can select what load case he wants to see, and the detailed text output will be generated. So that was all about the simple analysis results that user can see, and the advanced analysis results concerning the camber we will talk about in the later sessions. Now let me quickly tell you something about the design features available in MIDAS Civil. In MIDAS Civil, if you want to design any section, you can design the PSC section, you can design the composite section, or the simple steel section, and the concrete sections, reinforced concrete sections can be designed. The following steps have to be followed. You have to design, first of all, you need to define the design code. Then you have to define certain parameters such as the concrete material for design, the rebar ratio, the scale of factor, and certain other things to design the RC section. We will talk about the detailed designs of PSC and composite plate girder design in the coming sessions. And the development plan is such that in the next release, or maybe the next to next release, we would implement the design features for PC bridge, for Astro code, and we are also planning to launch the Eurocode design features for composite plate girder. We already have EC2 with which we can design, but we are trying to enhance the design capabilities in MIDAS Civil. Now let me tell you about the dynamic report. In MIDAS Civil, the dynamic reports can be generated. The user can save the images or the tables, and those tables or images can be used for the generation of reports. So as you can see in the works tree, the report, the following images, you can select the images which you click, and you can define the header and footer which will be used in the definition of reports. You can use the insert to report feature and the dynamic report will be generated. The dynamic report is opened through this feature. You can open a new document or you can open a previously opened document. Once you open the document, you can see Microsoft Word has been linked in MIDAS Civil so that the user can type and he can apply the images directly. So let's say I want to insert this image into the dynamic report, and I name it as model image. So the model image is available now, and I will insert it to the report. And the report has been created. As you can see, this report contains the image now. If I want to insert the tables, you can export this table by right clicking, and the table can be exported to be used to be implemented into the dynamic report. So this was all about the basic features of MIDAS Civil, and in the coming sessions we will take you through the detailed analysis options which are available for advanced analysis. And if you have any questions now, you can ask me through the chat window, and I will be more than happy to answer them. Mr. Kamal asked if we have the PDF copy of this example to practice after. Yes sir, we can supply you with several tutorials. I can supply you with the tutorials which you can follow and learn. Mr. Shan has asked a question, is this available for downloading? This webinar is available for downloading. Sir, this webinar will not be available for downloading. The videos will not be given to the users because this webinar is intended to give certificates to the users that they successfully attended this training sessions. So I'm sorry for that. A user asked, is it possible to create the combination of combinations? Yes sir, we can create the combination of combinations. As you can see here, I have created a combination and I want to create the second combination including the first combination. So as you can see, combination number 1 can be included and other load cases can be included. A user asked about the general section design and he wants to know something about the general section design. Well, right now, due to the time constraint, I won't be able to tell you in details, but I can just summarize that the general section design can be used to design any section. You can create a section here and you can obtain the moment curvature diagrams, the PM interaction curves. You can obtain them for a variety of sections. You can create your own sections and you can get the moment curvature and the PM diagrams. And we will include this general section designer in later sessions. Thank you, Mr. Ramesh. Okay, so Mr. Lee has asked about your example of this buckling analysis. How do you connect the plate elements with the beam elements? So as I told you earlier that when these, this is in reality, this is the same structure. It is the same girder. So we'll use the rigid link. So I have connected them with the help of rigid links. As you can see here, the line elements have been connected to plate elements using the rigid links. I think it answers your questions, Mr. Lee. Mr. Dimitris, he asked, Mr. Dimitris asks that if we are doing the settlement analysis, the settlement should be applied as positive or negative. The settlement must be provided according to the real scenario. If it is downwards as you've written, you will provide the settlement as negative. A user asked where we can get the PDF and the tutorials. The tutorials are available to be downloaded at www.midasuser.com. You can download the tutorials from there, and if you want any further help, you can send us the questions at esupport@midasit.com. I have typed the website, and you can click on this link and you can see the tutorials in the Midas Civil downloadable functions. We will send individual emails to everybody maybe tomorrow or day after tomorrow, and then you can fill the simple survey questions, and you can also request for the certificate at the time. Mr. Robert asked, how do we model lower E cross I on the inner supports by continuous composite girders? Yes sir, we can do that by applying the section stiffness scale factor. After applying the section stiffness scale factor, you can reduce the stiffness of the section, and if I'm correct, if you are talking about the cracked section, you can also simulate that characteristic. If you are talking about the crack section, you can define the crack section for the composite sections, and then in Midas Civil it can be analyzed as a cracked section. A user has asked for pre-stressing in RC box girder bridge. We can do the pre-stressing, the post-tensioning and the pre-tensioning can be done, and in the ongoing presentations which will held in other months, I will tell you where, how it has to be done. But right now, if you want to practice it, you can download the tutorial from midasuser.com. The link I have already given. You can download the tutorials from there, and you can apply the post-tensioning to the bridges. Mr. Siddiq Muhammad, he asked about the demo version of the software. Yes, you can download the demo version of this software from the same website and you can use it. You can download the tutorials. The trial version is available at the same website. You have to provide your email ID and you can download it. There is another question by Mr. Loria. He asked, you have displayed an option in which you can define different boundary conditions for different kind of analysis, and he wants more explanation. Dear sir, I would be more than happy to provide you any explanation further, but due to time constraint, it is better if you write me a mail at esupport@midasit.com, and I will provide you the detailed information on the same. Uh, Mr. Kamal asked for the email address, and I have already given the email address to you to the chat window. There is another question from Mr. Lalit. He asks, can we get our work report directly format from MIDAS? Sir, I would like to tell you here that if you want to generate the report as per your office requirements, then you can apply the header and footer in the reports as given in the format you want. You can just use the drag and drop feature of MIDAS Civil and the header and footer. Even the contents can be assigned to the report and you can then write whatever you want to write in the report. Mr. Antino, he asked, can a frame element be switched in plate element with any special function starting from the frame section definition? Sir, we can, as I showed in my presentation when I was modeling, that you can extrude the node element into line element, and the line element can be extruded to generate the plate elements. So this is how you can do it. Mr. Rui Elves, he asks whether it is possible to examine the effect of a specific vehicle position as well as envelope for moving load analysis. Yes sir, we can do that. For the moving load analysis, you can define the lanes and the vehicles as I showed in my webinar. And if you want to do this analysis for a vehicle position, it can be done in two ways. Either you can generate the static load case from the moving load analysis and you can input that load in MIDAS Civil automatically by using the MCT command shell. Here you can define the loads which is automatically generated by moving load tracer, and then it can be used for analysis. Further, if you want to do the analysis at other points, other positions, then you can apply the static load cases and the analysis can be performed. We would be signing out in about 10 minutes. So if you have any further queries, you can send the email to me at esupport@midasit.com, and by the time in 10 minutes I'll answer quickly the other questions. Yes, there is a question asked by Mr. Girinath. He asked, can external pre-stressing be done? Yes, sir, the external pre-stressing can be done by the civil. When you define the tendon property, you can define the internal tension, that is pre-tension, the post-tension, or the external tension. So this is how you can simulate the behavior of external tendon. There is another question by Mr. Siddiq Mohammed. He says whether the number of nodes and the number of elements, the number of members are limited. No, sir, there is no such limit. MIDAS Civil has successfully analyzed and designed big projects such as Stonecutters Bridge in Hong Kong, and there were thousands of elements used and the analysis was perfect, so there is no limitation as such. There is a question asked by Mr. Reynaldo. He asks whether you can export this model to AutoCAD. So you can export it here. You can go to File, Export, and you can export it to AutoCAD. And you can select some elements, or you can export all the elements. There is another question by Mr. Azizi. He asks how to analyze the heat of hydration analysis in MIDAS Civil in concrete bridges. We can do the detailed heat of hydration analysis. As you can see, MIDAS Civil provides extensive analysis options for heat of hydration analysis, and the user can do detailed heat of hydration analysis, and in the coming sessions I will show that, and you can also refer to the tutorials available at www.midasuser.com. Mr. Hilal asked when will be the next online course. Sir, I would like to tell you that the next online course will be somewhere in the mid of March, and we will send you emails concerning that, and the topic is already decided. The topic is construction stage analysis, and we will deal with the variety of bridge projects that MIDAS Civil can handle. I am typing the email address again. for those who haven't got the email address. There is another question by Mr. Juan. He wants to know about the different element types. So as you can see in MIDAS Civil, you can create truss element or tension only elements which fails in compression. You can also generate plate elements, or the solid elements can also be generated. There is another question by Mr. Alkes. He wants to know the seismic isolators are available. Seismic isolators are available, and you can define a variety of isolators, such as you can define general link for the same, and the general link properties. In the general link properties, you can define certain dampers, and LRB, lead rubber bearing isolator, can be modeled. I hope it answers your question. Mr. Antiano Angeles, he asked about the web seminar about the FCM bridge design. Yes, sir, it would be done. It would be in April, and you can attend that. Mr. Riento, he asked about the certificate of participation, and as I already told you that we'll send you individual emails tomorrow, and then you can ask for a certificate by clicking the link. Question by Mr. Dimitris. He wants to ask that why can't he see the stresses in the specific points of the cross section for the moving load analysis. If you go to the moving load analysis control and select on the stress calculation, you can see the stresses at various locations. Mr. Aloria, I would send you an email, individual email. You can ask, and I will tell you about the details of boundary change assignment to load cases. Mr. Zun asked my email address for technical support. Yes, sir. I remain available. All the emails that we receive on esupport@midasit.com, I handle them, and I will give you the technical knowledge, the technical queries if you ask any, and I will give you the solutions for the same. You can send me email at esupport@midasit.com. So that was all about this session, and if you have any more queries, you can send me an email at esupport@midasit.com and I will give you detailed description and answers for the same. And this is Nitin Malgudi signing off from this webinar. Thank you very much for joining the webinar. Have a great day ahead.